Hey everyone, this is Bradley Bush with another algebra video for you. Today we're talking about solving equations in quadratic form. Well, what is an equation in quadratic form? It's a good question, huh? If this is the first time to my channel, thanks for coming. And if you're coming back, thanks for coming back. If you enjoy it, please subscribe. So the answer to the question, what is an equation in quadratic form, is an equation in quadratic form is any equation that can be written as a quadratic given the right substitution. That's the key part right there. And any real number x that makes the equation 2 is called a solution. So let me give you two examples. So if your original equation was given x to the fourth minus 8x squared plus 9 equals 0. If we used the substitution u equals x squared, then watch what happens. Let's play around with this just a little bit here. Because what if we can rewrite x to the fourth as x squared quantity squared, correct? And then notice we already have an x squared in the second term. So if we use the substitution u equals x squared, then this x squared becomes u squared. X squared becomes u, and then we had that whole thing squared, and this x squared just becomes u. So in the end, we have u squared minus 8u plus 9 equals 0, and that is a quadratic. So the substitution u equals x squared made the original equation a quadratic. So that's why they say in quadratic form, because it doesn't start out as a quadratic, but you use a substitution to make it into a quadratic. Let's look at another one. The original equation is 4 times x to the 2/3 plus 11 times x to the 1/3 minus 5 equals 0. So if we use the substitution u equals x to the 1/3, then watch what happens. The x to the 2/3 really can be written as x to the 1/3 quantity squared. Because when you multiply something raised to a power, all raised to another power, you just multiply the exponents. So that gives you 1/3 times 2, which is 2/3. And then we already have an x to the 1/3 next to the 11. So if we make the substitution, then watch what happens. The x to the 1/3 becomes u. We have another u down here. And we get u squared in the end. We get 4u squared plus 11u minus 5 equals 0, which is a quadratic. So there you go. They're two perfect examples. Let's solve some of these equations. So the reason that we like to change something into a quadratic form is because that helps us solve the equation, because we have very defined techniques for solving quadratics. So let's see this problem here. So this problem, this is example A, and we have x to the fourth minus 5x squared plus 4 equals 0. Our substitution is going to be u equals x squared, and then we're going to rewrite this. So let's say we have x squared minus 5x squared plus 4 equals 0. Now, the x squared, we have a couple x squareds here. I just highlighted them in red. Those can be changed because we're using this u equals x squared as our substitution. So that means that this x squared is going to be replaced with u, and this x squared is going to be replaced with u. So what do we get when we do all of that? We get our new equation, which is u squared minus 5u plus 4 equals 0. And now we can solve this. So let's solve that equation. So here we go. We have u squared minus 5u plus 4 equals 0. If we factor this and solve, then we get x minus 4 and x minus 1. Whoops, not x, but u, right? Because that's our new variable. So we set both these equal to 0 and solve. U minus 4 equals 0. We can add 4 to both sides, and we get u equals 4 is our first equation. Our second equation, u minus 1 equals 0. We add 1 to both sides, and we get u equals 1. There we have our two answers. But remember, our original equation is not in x, or is not in u, it's in x. So we have to substitute back in. So we use our substitution because we know that u equals x squared. So we've got to replace u in both of these situations with x squared. So that's x squared, and that is x squared. And then we have our answers. So let's come back up here. Let's do u equals 4. That's really x squared equals 4, right? Because u equals x squared. That was our substitution. Now we can take the square root of both sides, and we get the square root of x squared equals, we'll have a plus or minus 4. Lucky for us, the square root and the squared cancel, and the square root of 4 is 2. So we get x equals plus or minus 2. There are two of our equations. There's two of our answers here, plus or minus 2. And let's try our second one. U equals 1. Well, that really means x squared equals 1, because u equals x squared. That was our substitution. Now we can do the same thing. We can take the square root of both sides. We have a plus or minus on the right, and we get x equals plus or minus 1 because the square root of 1 is 1. So we have two answers here, plus or minus 2 and plus or minus 1. We can verify that these are indeed answers by plugging them back into the original equation and verifying that we get 0 equals 0. But these are valid solutions. Let's do another one. This problem is x to the 3 halves minus 2 times x to the 3 fourths plus 1 equals 0. Well, let's, how about we try x to the 3 fourths as our u. If that's the case, then how can we rewrite everything? We notice that x to the 3 fourths squared minus 2 to the 2 times x to the 3 fourths plus 1 equals 0. Notice here, I have x to the 3 fourths. Let's change that to red. Let's change this x to the 3 fourths also to red. So this works perfectly because if we multiply 3 fourths by 2, we get 3 halves because the 2 and the 4 do some simplifying. The 2 goes away and we get cancels with 1 of the 2 in the bottom with the 4 and gives us 3 halves. Or in other words, let me write it out here. 3 divided by 4 multiplied by 2 gives us 3/2. So it's perfect. That's a perfect substitution. So that means now that this is u, and this is u. Everywhere there's an x to the 3/4 in our equation, we replace it with u. So our new equation is u squared minus 2 times u plus 1 equals 0. We can factor, and we get u minus 1 times u minus 1. We set both of those equal to 0 and solve for the same thing. So by the way, we'll get the same answer for both. That helps us. U minus 1 equals 0. We can add 1 to both sides. And we get u equals 1. And by the way, we get the same thing over here on the right side. U minus 1 equals 0. U equals 1. So we need to go back into xland because we know that u equals x to the 3/4. So we've got to go back and fix this. We have our answer u equals 1. That really means x to the 3/4 equals 1. This is an equation with rational exponents, and to solve that, we're going to raise both sides of the equation to the 4/3 power. That cancels the exponents on the left, and we get x equals 1 to the 4/3. If you take 1 to the 4th power, you get 1, and then if you take the cubed root of 1, you just get 1. So that just gives us x equals 1 as our only answer. And again, we can plug that back in to our equation, and we see that we get 1 minus 2 plus 1, which is 2 minus 2 equals 0. So it's a valid solution also. Kind of a cool way to handle equations. By the way, this type of idea of substitution is one of the techniques that is very useful the further you go in mathematics. So this is a great technique to use. Our last problem here, problem C, is quantity x minus 5 squared minus 4 times quantity x minus 5 minus 21 equals 0. And if we choose x minus 5 as our u, have you noticed a pattern here? Have you noticed the thing that's in the linear, the one that's in the middle, is usually what we choose as the substitution? Just a little hint there. That's very often the case. And I'm going to rewrite that x minus 5 just because I think it looks terrible. There we go. So if we rewrite this problem, this becomes, well, it's easy. We can do it right here. Let me circle. Let's highlight all of the x minus 5s. So I just changed them yellow. So you know now that that's u and that's u. So we get, when we rewrite our problem, we get u squared minus 4u minus 21 equals 0. And when we solve this, we can factor. We need factors negative 21 that sum to negative 4. So let's try u minus 7 and u plus 3. we set the first term equal to 0, u minus 7 equals 0. That gives us, we take the 7 to the other side, we get u equals 7. There's 1. And it's kind of hard to choose a color, right? There's so many options. U plus 3 equals 0. And that take the 3 to the other side, and we get u equals negative 3. So we have our two u's that we've just solved for, but our original problem is not in u, it's in x. So we have to convert back to x's. So let's do that. Let's convert back. We had u equals 7. We know u really equals, what does u equal? Let's remind ourselves. U equals x minus 5. So instead of u there, we're going to have to put x minus 5 equals 7. And then we solve for x. So we can add 5 to both sides, and we get x equals 12. If we plug that back into the original, we would see that that gives us a true statement, so that is a valid solution. Let's try our next one. Our next one is u equals negative 3. So again, instead of u, we have x minus 5. And we add 5 to both sides. And what do we get? X equals positive 2. We could also plug that back into the original equation and see that we got a true statement, 0 equals 0. So our two answers here are x equals 12 and x equals 2. Hope this was helpful. Hope you enjoyed it, and hope you have a good day.